Question 18, we have a small smooth sphere moving on a horizontal floor with speed 2u. It strikes an identical sphere lying at rest. Okay, so let's call these masses m. M and m, 2u and 0, p and q. This might be 4 after and mass. So let's try and do this without the formulas here. We've written them out in all the other questions. P minus q over 2u minus 0, just 2u, is equal to minus e. So P minus Q is equal to minus 2EU. We also have V1, that's V1 minus V2. So MU1, so 2MU plus 0 is equal to MP plus MQ. Dividing by M, so we get 2U is equal to dividing by M, 2U is equal to P plus Q. We have a minus Q on the other one, so P minus 2EU is equal to P minus Q. Adding these equations, we get 2P on the right is equal to 2U minus 2EU. And dividing by 2, we get P is equal to U minus EU. And factoring out the U, we get P is equal to U times 1 minus E. So that's the speed of the first one, this U times 1 minus E. Similarly, we'll get the same thing, we just sub back in for Q. We get up the top here, we can get Q is equal to P plus 2EU. So Q is equal to this P, and I'll take this version of it for now, U minus EU plus 2EU, which will give Q to be U plus EU. So Q is going to be equal to U times 1 plus E. U times 1 plus E. When the second sphere hits the wall, the spheres are a distance this much apart. So we have the speed it's going, and we have the distance it is from the wall, and we're looking at the second sphere, so we're looking at Q here. So here's my Q, speed. The distance S is equal to 1 meter. And we're asked to show when the second sphere hits the wall, the spheres are a distance this much apart, okay? Okay, so what's going on here? We have ball 1 hitting ball 2, a meter from the wall. This ball 2 then gets to the wall, this 1 meter gap here. So what do we have? We have speed, it's going, and we have distance. So we should be able to use our DST triangle here. DST. We'll be able to find out the time taken to get there. And we also have the speed of P, and we can tell how far he has gone in that time. And then we can get the difference between it and the 1 meter that the other guy has traveled. That will give us the distance apart. So the time taken to get there is 1. Time is equal to distance over speed divided by U over 1 plus E. I think this is the right approach to take. So it's taken that long to get to the wall. So at this impact point, it's taken 1 over U plus E. So the P has traveled in that time. P, we have speed. Now we also have time, so we can get distance traveled by P in this time. Distance is equal to speed by time. I'll write speed here so we don't confuse our S's. So this distance traveled is going to be equal to the speed, which is U times 1 minus E, by the time taken, which is 1 over U times 1 plus E. So the U's will cancel, giving a distance for the second sphere. The first one that was moving, it has traveled a distance of 1 minus E over 1 plus E. So if we come back to our little diagram, this guy is here. The other guy has moved so far to here. So what's the difference? So it's 1 minus whatever the distance this guy has traveled. So 1 minus this guy here will tell us how far they're apart. 1 minus E over 1 plus E. So we create two fractions. We're going to get 1 plus E minus 1 plus E over 1 plus E, or 1 times 1 plus E. So we're going to get 2E over 1 plus E. Is that correct? 2E over 1 plus E. It is correct. We're asked to show the next collision takes place at distance 2E squared over 1 plus E squared from the wall. Okay, let's have a look at what's going on here. We have the same masses. have them traveling at different speeds now. We don't know their speeds afterwards again, P and Q. And what are their speeds? Well, we should probably call it V1 and V2 because we have P and Q here already, but P is traveling at U times 1 minus E, and U times 1 minus E, and Q we got to be U times 1 plus E. So Q is the one heading towards the wall. So it's going to hit this wall and it's going to rebound with a new speed. So this is its old speed and it's the new speed. And what do we know? Old divided by new is equal to minus E. It's the other way around, isn't it? New versus old. Yeah, new versus old. New versus old. So your V1 on top and your U1 on the bottom. Or your V1 minus V2 if there's two of them. So we have, well, let's call it, we're calling it the new speed Q. So we can say that Q divided by U times 1 plus E has to be equal to minus E. So the new speed of the sphere hitting the wall is minus EU times 1 plus E. There's an E squared there and there's an E squared in the answer. So it looks like we're on the right track here. So that's the speed of Q after it rebounds from the wall. So we now have one of them traveling in this direction. The other one has hit the wall and it's gone back in this direction. So I think we can use relative velocity here. We have the velocity of A and the velocity of B. So the velocity of A relative to B is the velocity of A minus the velocity of B. So will this help us here? Let's have a look here. The velocity of the first one is U times 1 minus E. U times 1 minus E. And then we'd have to take away the velocity of B, which we've got to be this new Q. So it's actually going to be a plus EU times 1 plus E. So this is going to be the relative speed to cover the distance. And we know the distance from earlier that needs to be covered. So this is U minus EU plus EU plus E squared U. These cancel and we're going to get U minus E squared U, which is U times 1 minus E squared, U minus U E squared. So this is the velocity of A relative to B. I'm just seeing I took this minus sign instead of this plus sign. Just be careful not to make silly mistakes at this point of the question. So now we have speed. We need to know the time taken to get there. To get to the collision, and we know the distance that they're apart. So this is the distance that they're going to cover, the two of them going at different speeds, which is why relative velocity will help. So the distance apart, what's this distance? 1 minus E and 1 plus E? No, it was this guy here, wasn't it? It was 2E over 1 plus E. So 2E over 1 plus E is the distance. 2E over 1 plus E, that's the distance they are apart when they hit the wall. So when they connect next, they're going to have traveled that distance. So if they're that far apart and they connect somewhere here, this one plus this one will always be the same as the full distance tree. So we have our time from our DST triangle is equal to distance over speed. So relative time is going to be the relative distance, the 2E over the 1 plus E divided by the relative speed, which we just got to be U times 1 plus E squared. And I hope this is taking us in the right direction. So that's like a fraction. We turn that upside down and multiply. So then both the denominators will stay there. So we're going to get 2E over 1 plus E times 1 plus E squared. And the U is there as well. So that's the time taken to get to the collision point. We also have the speed of both of them. So we have the speed of 2 going in this direction. So I've got my time. I've got my speed up here. So distance is equal to speed by time. So the distance that they're going to have traveled is going to be U by 1 plus E squared multiplied by the time, which is 2E. I'll put the denominator and line it up. 2E over U times 1 plus E times 1 plus E squared. So we do have some cancellations here. The 1 plus E squared and the U So the distance traveled looks like it's 2e over, have I left an e out? I think I have taken the wrong speed here. I took this guy and I should have been taking this guy. The speed of b, not the relative speed of both together. So let me just redo that. Ignore that one above. So the distance is going to be the speed eu times 1 plus e divided by, or sorry, times 2e. So there's 2e down here, the time over u times 1 plus e times 1 plus e squared. So now what will cancel? The u will cancel and the 1 plus e cancels, leaving us with 2e squared on top and 1 plus e squared on the bottom. Hopefully that's what they were looking for. 2e squared over 1 plus e squared gets us to the answer.